Good morning guys, and welcome to the third and final part of this little amount of substance worked exam answer mini series. So today's the final part because I'm going to do part C and D in this final video. If you missed parts A and B, they were posted yesterday and the day before. Just wanted to keep these videos a little bit shorter, that's all. So carrying on, we're now looking at part C. So we're still thinking about making zinc chloride in this question, but we're making it in a different way. We're using zinc, not zinc oxide, and thus we get hydrogen and not H2O. Now, again, this question is asking us to use different skills from what we've used in the previous two parts of this question. We are being asked to think about the percentage purity of the zinc metal. So the first thing that we're told is that we have an impure sample of zinc powder, so it's not pure zinc, there'll be other things in there. And the key thing with these sorts of questions is that we're assuming that the impurities aren't, well, they're not going to react and make zinc chloride, certainly, but in other impurity questions, usually the impurities are unreactive impurities. So we can just think about working out the mass that is actually the thing reacting. In this case, we're going to want to work out the mass of actual zinc in this impure sample. So we're told that that has a mass of 5.68 grams. That was then reacted with hydrogen chloride gas until the reaction was complete. And we're then told that the zinc chloride that was produced as the product had a mass of 10.7 grams. We are trying to find out, as I said, the percentage purity of the zinc metal. And we're told specifically here to give our answer to three significant figures. Now, as in the question before, I talked about significant figures. We should always be having a look at the number of significant figures given in the question for any values that they've provided us with. So they've given us two masses, both of which are to three significant figures. So that's what we'd be doing it to anyway. But of course, whatever it specifies for you to do, please do. Okay, so what some students may do in this question as a starting point, which would be the wrong thing to do, unfortunately, is they would take the 5.68 grams of impure powder and they would then use the AR of zinc to calculate the moles of this. The reason why we can't do that is because this isn't all zinc, so we're going to have to work backwards this time. And the first thing we're going to need to do is get the moles of the zinc chloride, to then get the moles of the zinc using this 1-to-1 ratio, to then get the mass that is just zinc and then compare that to this 5.68 grams. So again, to help me lay things out, I'm just going to write out the equation. So we're told the mass of zinc chloride is 10.7 grams. And we used the MR of zinc chloride in yesterday's question. So forgive me while I take a sneaky peek at that. 136.4. And then the number of moles is equal to 10.7 divided by 136.4, because it's mass divided by MR. And that gives me moles of 0.0784. I'm going to write it to three significant figures, but I am going to leave the whole calculator display on, and it is 0.078445. So it's, yeah, if I then just use the three significant figures, I am going to get a slightly different answer. And whilst that will be accommodated in the answer in the mark scheme, I think it's good practice to keep the whole calculator display on wherever possible, but also not write the whole calculator display down in your working out. Okay, so we've got our equation, we've got our moles now of zinc chloride. Because the ratio is 1-to-1 between the zinc chloride and the zinc, we can say that the moles of the zinc is also going to be 0.0784 to three significant figures, and the AR, the relative atomic mass of zinc, is 65.4. So then I can times them together because mass is moles times MR, and that will give me the mass that is just of zinc, pure zinc, that is a part of that impure powder. So them two times together gives me 5.13 grams. And again, going for 3 significant figures, which is what we're going to be giving our percentage purity answer to in a minute. So we now know how much zinc had to have been present in the powder to be able to make that 10.7 grams of zinc chloride product. Had we have had any different mass of zinc, we wouldn't have got that mass of zinc chloride, and that's why we're able to work backwards in this way. So we've got the moles of zinc chloride, therefore we figured out the moles of zinc we should have had in the first place, and then the mass of the zinc that we should have had in the first place. So percentage purity is then a case of us taking the mass of the pure zinc, 5.13, dividing that by the total mass of the impure zinc powder, and then timesing that by 100, and that will tell us how much of that impure powder as a percentage was actually zinc. So that gives me 90.323, so to 3 significant figures, 90.3%, which is not too bad, but if we were using pure zinc, we'd have a greater mass of zinc, so a greater number of moles of zinc, greater number of moles of zinc chloride would be made, and thus we'd have a greater mass of zinc chloride being made. But I have seen worse purities than that. And that would be how we'd go about doing that question. And then the final question isn't a calculation, it's tied in some structure and bonding. It wants us to predict the type of crystal structure in solid zinc fluoride and explain why its melting point is high. 3 marks. So this is a question that you could have answered at GCSE. So zinc fluoride. Zinc is a metal, and if we weren't sure whether zinc was a metal or a non-metal, 2 things. We can look at where it is on the periodic table. It's at the very right-hand side of the D block in the top row, and also it says zinc metal in the question above. So zinc is a metal, fluorine is in group 7, so fluorine is a non-metal, and whenever we have a metal and a non-metal bonded together, they will bond via ionic bonding. So the type of crystal structure in zinc fluoride is going to be a giant ionic, or a giant 3D ionic lattice structure. And all of our giant 3D ionic lattice structures, if we want to melt them, we'll need to have all of those strong ionic bonds broken. And that takes a hell of a lot of energy to do because ionic bonds are very strong. So I've done the first part, I've predicted the type of crystal structure. Now I need to explain why its melting point is high. So this is made up of many strong ionic bonds, which are strong electrostatic forces of attraction between oppositely charged ions which take a lot of heat energy to break. Thus, high melting point. Hopefully that feels okay. Both parts of that question feel okay. But if anybody has any questions about percentage purity or come across any other questions they'd like me to have a look at, as always, please let me know. Likewise for the structure and bonding answer, if there's anything that I said that doesn't make sense or you'd like to clarify with me, again, please do just ask. Thank you for watching the final part of this little three-parter of worked exam answer videos on this very long amount of substance question. That was 14 marks in total for all of the parts of that question. So if you are a big fan of amount of substance, then that would have been very lucrative for you. If not, clearly we need to get a little bit more comfortable with it. And if I can help with that in any way, just let me know. Hope you have a really good day, guys. Thank you so much for watching.